define to decide what aims should this model apply for, and what the techniques and we should use the simulation model. For the aims, as I say, this model should reduce the real behavior of the system, the operation, the constraint, the equipment behavior, the stochastic environment. Should also provide a good and beneficial assistance to the decision makers, and also to be very manageable, very easy and manageable tool and model, and also flexible. For the conception here in our model, we have choose agent to represent human and object to represent infrastructure and resources, because these are passive entities. And for activities and processes of the terminal, we have used discrete event model to model this time. So this approach was actually defined through different projects we have done before. Design different simulation models for different kind of container terminal in the harbor and in by region. In addition, there is also literature different methodologies and approaches that are proposed to make different kind of simulation of the models for different kind of complex systems. That we can say that this approach are stated in 4 steps: inception, analysis, conception, implementation. But the problem is that this linkage between these steps are not well defined. So this approach tries to give some recommendation that can help to go through this process in order to build a good simulation model for rural and container terminals. So this is our studied system, is the Nordic port. So it is divided in 2 terminals. The upper terminal is the container terminal, and the bottom side, and in the left side is the rural terminal. So this is a brief description of our approach. Is a 4-step approach with in each step is sub-steps, and as I say, there's the linkage between the different steps that we will define and we'll explain later. So in the first step, introduction, so we try to answer to who and what question first. We try to limit the context and the boundaries of our system. So what kind of things we'll focus on, and the abstraction, also the level and the objective and the requirement that the model need to apply for. And the second sub-steps is the system description, concerned to define the different actors, entities, the functional and non-functional requirement, and the functional and physical organization of the system. So, and the third step, so we will refine the functional and non-functional requirements in use case, like for every entity or every actor, what like tasks it is doing in the system. So to make a use case model for the system. So this use case is briefly described in the table at the bottom of the slide. So the next step is to go through this use case, analyze each use case, to ask to this the how, why, when, and where questions. First, we use descriptive sheet, to enroll each use case. For example, to describe the main and second actors that are involved in doing something in the use case, the events, the condition, the constraint, and main and basic scheme of actions. So this will be translated in a graphical representation through activity diagrams. So all of these artifacts that are produced in this second step will be aggregated to make the foundation of the simulation model that will be the linkage for the construction step. So this model that like represent the main flow of actions in the main process that should represent the basic of our simulation model. So in the conception, we will try to may go in deeply in the conception and analysis of the designed global model. First, we'll try to model every entity there, either with agent paradigm or object paradigm. Then we will try to classify, for example, agent in multiple subsystems. Here, in our case, the agent are classified in controlling agent that have like decide on the operations, decide on the incoming flow, and the agent that make decisions. Representing subsystem that the system that represent the equipment, the agent that are executing orders, and this also can be applied on the other entities. After that, so we have the global model, we should divide it in sub-models in order to be either manageable and also to be flexible. So in our case, we define five sub-models. The operating sub-model represents operations and processes, planning that represent decision, and the feeding sub-model that represent like the protection or like the creation, the generation of physical flow, containers, vehicles, and transportation modes. Displaying sub-model that is the dashboard that display key performance indicators of the operation and activities. Supporting sub-model that represents the facilities and the equipment, like the agent and the resource. So this is how these sub-models are specified inside the system. So we have three levels. The TCP model is represent the flow, represent the feeding model that generates physical flow, planning and operational model that simulate the operation and the decision inside the system, dashboard that display the performance indicators, and the supporting sub-models which call the resource model that contain actors and entities. So here is the operating model, planning model designed for the RoRo and container terminals in the Nordic port. This is how the decisions are classified. This is the object resource model, the entity model actually. Here the actor, the agent model. So then we should implement this model. So here we have used in logic for that purpose. Then we have validate this the conceptual and the implemented model with subject matter expert and partners. And then we have used this model to make some experimentation, to investigate system handling limits, and to try with to evaluate different strategies. These are the obtained results from these mesh models. And thank you for your attention.
Thank you very much. Thank you. Mohamed. Mohamed, before we start with discussion, may I ask you to introduce you shortly? Sorry, I forgot to ask it in the beginning of your presentation. Could you please introduce you?
Okay, my name is Mohamed Nezar Abourraja. I'm a postdoc researcher in the KTH Royal Institute of Technology in Stockholm. So I'm working basically on making simulation models for logistic systems like RoRo and container terminals, basically using like in-logic simulation software. And then this work is about like proposing like an approach that can help to make and build simulation models. That this approach is like a result of our experience of making like simulation model in previous works and projects.
Thank you. I see. Thank you. So now it's time for discussion. Dear colleagues, please, if you have any questions, just indicate with raised hand in the system. Okay, maybe I could start with the discussion. I'm wondering what was a motivation for your research?
Actually, the main motivation is that there is no like in the literature, as at the best of our knowledge, there's no like approach that can help to build simulation model for specific model for container terminals. So there is like many like generic approaches, but here we try to make like a giveaway that can help to build models for specific model for containers and RoRo terminals. So yeah.
I see. Thank you. And at which stage now you are with your PhD studies?
I'm postdoc. I have already made.
Yeah. So I mean, how much time passed after your presentation of your thesis, and what about your plans for the next step after the postdoc position?
For now, I have like new like position with a researcher for 2 years actually, for 1 year actually. So then I will look for like having post like assistant professor in somewhere.
I see.
The industry, so that's depend on the future.
So let me, on behalf of participants of this session, to wish you all the best in your future developments.
Thank you.
Thank you. Okay, fine. So now it's time to move to our second paper. The paper will be presented by Dr. Lawrence Henesey. Lawrence is with us. Fine. The title of the paper is Smart Container Stacking in the Yard, the paper number I3M54. Lawrence, maybe before we start, you could shortly introduce yourself, where you are at the moment, and so on.
Oh, yeah. Good morning. I am today in Dubai, helping DP World, one of the largest container terminal operators with around 80 terminals worldwide. I'm working with a software called Zodiac, which is a terminal operating system that is being delivered for the next 3 years to various sites around the world. So I will be presenting a bit on my research on container stacking. If I may ask, do you need me to play the video, or can you play that video for me? Which is the preference? I have a.
Maybe you could start. You could start, and if we have any technical problems, then Mohamed will help.
As a backup, I do have on Vimeo. So let me go ahead and see if I can play this.
Yeah, let's try.
I will start. Let me do that right now. And if I have any issues, then I'll raise an alert.
Yeah.
Okay, I think you can see my screen, everyone.
Exactly.
Okay, I'll play the video then.
Perfect. Thank you.
I could not hear the voice.
Some problems with voice.
I politely ask that you play it on your side because I'm having an issue here.
Fine. Mohamed, please help us.
Maybe Mohamed can share the video.
Mohamed, you are with us? Jessica, maybe Mohamed is here? No?
I think yes, but I don't know why he's not answering.
Okay, well, what I can do real quickly, I do have the video link, so everyone you can play that.
Maybe I can share it from my screen.
Yeah, okay. Jessica, would be good.
I'm not Jessica.
Maybe yes. Yeah, we can try. We can try. Or if you prefer, you can send me. But it works in this way.
Can you?
Hello.
Yeah,
and hear it?
Yes, I can hear it. Go ahead. Institute of Technology in Karlshamn, Sweden. I'm here to share with you our research on smart container stacking in the yard. I'm speaking on behalf of Bleking Institute of Technology. I'm also accompanied by Alexander Silenosov from Bleking Institute of Technology, Christopher Meyer and Lima Gerlitz, both from Hochschule Wismar in Wismar, Germany. This is paper 54. So the problem is that ports and terminals are facing a lot of dilemmas. So with increasing competition of terminals, we're seeing also the rise of globalization, more and more bigger ships, faster ships. The costs and energy are also spiraling and also increasing. The environmental demands have also increased over the years. So the consequences is that we demand more efficient systems, new investments in modern port facilities, bigger cranes, faster logistics, automation of container yards, and electrification of green terminals. So these are the trends and consequences that we can say characterize this domain. Regarding to the philosophy of many ports and terminals is that we also argue with the philosophy that the performance is steered by the container yard. And the reason for this, I will go into more discussion, and really is the aim of this project was to understand how we could improve the container yard management so that we can help improve total container terminal performance. And we say that it's steered. That means it's controlled, the yard, by the housing, by the management and the selection of containers to various lots in the yard. So this is another picture for optimizing container processes. So we can see when the ship comes to the port on the water side, we see that currently 55% of the operations can be optimized there. The yard storage, we see approximately 75% currently we're able to optimize. And then on the land side, this is a 80%. So we feel that focusing in the yard and the storage area, this is where we can focus on enabling the port to be more productive. And we feel the stack is the main problem because low service levels is the main reason contributing to other container handling processes. So I think this is a very good slide. It shows you the relationship between the water side, the yard storage, and the land side, and how they all affect one another. So with yard capacity, the three determinants are the yard capacity, our area, density, and dwell time. The normal KPI is throughput per acre. We also look at transshipment cargo. This is where cargo is coming in and off the vessel, but not going onto the hinterland. We also are looking at various or analyzing, evaluating different equipment types and storage densities. So our methodology is that we have applied a discrete event simulation that consists of a simulation method for modeling the stack and the containers in the yard so that we can avoid, or rather minimize, the number of times that the container has to be reshuffled or touched or moved. So we are evaluating a genetic algorithm in which we will calculate the maximum fitness for approximately 150 containers to store at the best location in the yard. And we were able to obtain this list from a local port. So the solution will be based on groups of 3 values, and we shall find hopefully the best possible location to store a container in the stack by using a simulation tool to help evaluate the genetic algorithm that we employ. And we also will look into the containers with early delivery date. And finally, I'd like to share with you the research process. So initially, we conducted a literature review where we specified the area research, identified the gap, and then we came with a number of questions. And then this led to a mathematical modeling where we would define notation and build the model. And then this led to the simulation modeling where we were working with the designing of the model, optimization, where we were evaluating, comparing genetic algorithm with taboo search, and then the simulation model itself. And then with the results, they were obtained after conducting the verification and validation. So this gives you a bit of more clarity on how we pursued, or rather conducted, this research. And we also did a comparison of simulation tools. We were evaluating FlexSim, Arena, and AnyLogic. In this research, we have used the AnyLogic. We found that to be the most appropriate simulation tool in conducting this study. The parameters of the genetic algorithm are here identified. So as I said, 150 containers, crossover rate is 50%, mutation rate is 0.016, and the determinant size is 5, and elitism is true. So in this sequence diagram of the stacking, we are having AGVs or trucks coordinating with the container for pickup, and this will be a check delivery date with the crane. The crane is an object where it will also contact the storage system to find the location of a container from which the storage system will give, or rather provide, the best location in which the crane will then store this position of the container. So this is the flow that we adopted into our simulation model. Regarding to the simulation experiments, what I am presenting to you are the input, the sample value, and the type of value that we used. We have a short explanation for each one of the IDs. Then, of course, the resources. We were evaluating 5 AGVs, 1 yard cane, and 3 trucks. So from the simulation work, this is a screenshot of the container stacking using the AnyLogic tool. This was very helpful for helping us to identify and get clarity of what was taking place with the model. Here is another view of the AnyLogic. This is a 3D, and this is very good for observing, making sure that the containers are behaving as they are supposed to. So the results that we obtained from the AnyLogic were then used for comparison of the genetic algorithm and the taboo search. So we could see that the fitness value was quite high, and the taboo search accuracy not as high as the genetic algorithm in this scenario. We also did a fitness cost achieved by the simulation-based genetic algorithm. And finally, I think it's very important when we do these type of studies that we do a validation and verification. So with the validation and verification, we performed a debugging. We also did a modular testing of the simulation model. Sensitivity test was also executed. And finally, the results of the verification and validation were conducted, in which we could see that to verify the performance of the genetic algorithm, it was better than the taboo search, namely because the results show that the increase in the population size has not so much of an impact on the performance of the genetic algorithm. So the conclusion is that the simulation-based genetic algorithm has shown that it has an impact on unproductive moves, minimizing these unproductive moves, and also provides a high accuracy in delivery dates of containers. So that is obtainable. The cost and time, both factors, are affected due to the inefficiency of this stacking system. And we also noticed that we can take control of these factors indirectly by improving the unpredictable moves by using the genetic algorithm. And finally, we have made a comparison between the results of the genetic algorithm and the taboo search on the same problem. And this helped to help us to evaluate which one of these applications is best to solve this problem. So we found that the genetic algorithm has performed well to solve this particular problem and provided an optimal solution. I thank you. And on behalf of the Connect to Small Ports, which is an EU-financed project which helped partially in financing this research, I thank you. I have my coordinates for those that would like to have further information, and many, many greetings from Karlshamn, Sweden.
Thank you.
You're on mute. You're on mute.
Yeah. First of all, many thanks to Rike Lieder from Biba Bremen for very kind help in running the presentation. And Mohamed, are you with us now?
Yes, I'm here. Sorry, I had
actually missed you at the moment when you were most needed. Okay, fine. And now again, Lawrence, many thanks for your presentation. And now it's time for the audience to ask the questions, please. We're looking forward to the questions. Yeah, Kirill, please go ahead.
Okay, thank you for your presentation. I have a question. Okay, you tell that genetic algorithm performs well in this bigger population, but have you tested some potentially big simulator with maybe tens of thousands of containers in yard? And another part of the question is how much time usually it requires to perform optimization for your tests?
Good question. This was a initial, if I may call it a pre-study. So we are actually looking at, as we speak, at a 8 million TEU terminal. And just so happens to be where I'm located. So we are looking to evaluate with genetic algorithms. So far it is taking time. We're having to rework with the solution. The simulation's going slow right now with the AnyLogic. So this is a bit of an issue here. So I think what we may do is that we may just drop the AnyLogic and just go with a pure simulation and an evaluation with the genetic algorithm. That's what I think we're going to do, because it takes too much time.
Okay, great. Anyway, I think it's a great initiative, and thank you for your presentation.
And just to add it, just to be very clear, is that this was only one stack, one crane, 5 AGVs. So it's a very basic. It was more or less to, as I said, like a pre-study to test to see what we could do. And I think it's for me personally, I think it's good when we do research that we try to compare with other, I want to say, techniques and technologies that are out there, such as optimization. So we did look at taboo search. Obviously, there's other optimization, I want to say, solutions that we could also evaluate, such as simulated annealing, Lagrangian relaxation. So anyways, that was the start of this research. So thank you, Kirill.
Thank you.
Do we have any more questions?
I have a question.
Yeah, please. John.
Jawad Boukachou from France. Thank you for your presentation. I want to know how you combine optimization and simulation.
Oh, we did not combine optimization and simulation. What we did is that for the optimization, we were evaluating the taboo search. For the simulation, we were simulating the genetic algorithm, and then using the same data set, we could then do a comparison. And what we achieved was that with the genetic algorithm in the simulation model, we could address that it was performing better than the taboo search. So I apologize if I give you the idea that we did simulation optimization at the same. No, we didn't do that.
Okay, thank you. Thank you.
Sure. Yeah, clear.
Thank you. Any more questions, please? Not at the moment. Again, Lawrence, many thanks. And thank you very much for being with the conference for 3 or 4 years.
It's going on the 3 now, 3 years.
So the 4th one will be the next one.
Yeah, hopefully in Rome.
Okay,
thank
see you then. Okay, thank you. Fine. So now we could move to the next paper, the 4th paper, I3M59. Do we have a presenter with us representing the team of the authors? Mohamed, do you think that we have the presenter with us? Actually,
Yes, I actually searched for her, Catherine Smith. If she's here, please raise her hand or just make us understand that she's here.
I'm afraid, but at least I don't see Catherine in the list of participants at the moment.
Yes. Otherwise, what we do normally is to share her video. Yeah. But unfortunately, she haven't shared the video with us. She shared just a PowerPoint presentation. And in this case, I suggest to go forward for the next presenter.
Okay.
So yeah, so we can catch the time.
So now we move to paper number to the 4th paper at our schedule. So paper number I3M 154. And do we have somebody from the team of authors who is going to present?
Yes, good morning.
Yes. Okay, perfect. So maybe then we ask Mohamed to run the presentation, and then, but before, maybe you could introduce you shortly about yourself.
Okay, thank you very much. Good morning to everybody here. I am Marco Frosolini. I am Associate Professor in the area of logistics and Industry 4.0 Technologies Applied to Logistics in Pisa University, Italy. And I'm presenting an experimental study that we conducted in the port of Portoferraio, Italy, Elba Island, relating to safety and communication issues with port users.
Thank you. Okay. Mohamed, could you please start the presentation?
Sure.
Yeah. Thank you. Good morning. My name is Marco Frosolini, and I am Associate Professor at the University of Pisa, Italy. I'm here to present the outcomes of an experimental project that I carried out with my colleagues, whose names are shown in the presentation, relating to an integrated communication system for the port emergency tourist flows management
based on drones, RFID tags, and a rewarding system. After a brief introduction, I will shortly report the state of the art on the subject, and I will discuss our experimental approach. Finally, I will present the outcomes and our conclusions. It is known that in recent years, unmanned aerial vehicles, also known as drones, have gained an ever-growing importance. While their initial application was limited to a few tasks, such as, for example, photography and mapping, small item transportations, and some emergency light tasks, the improvements in technology allow today for a larger number of potential activities. In particular, our attention is focused on management of emergency events due to climate changes, human-related incidents, pandemic, or even other causes. The presented approach is front-minded at the communication stage among drones and humans in port and periport areas, with the aim of creating a timely and effective event-driven alert system. We all know that usually communication in ports and the surrounding areas is performed mainly by means of microphones and variable message panels. But this is certainly a weak solution. Indeed, these are generally insufficient in emergency situations due to a number of aspects. Some examples are traffic diversions, differentiation by vehicle, location, and context. The need to send passengers and cars to areas other than those reserved for freight vehicles, and above all, and most important, heavy vehicles and dangerous goods. In brief, we need to find a way to provide different information to different port users based on the location and the consistency of a passenger class, the number of passengers. In the present work, an event-driven integrated system is presented that allows a continuous communication between drones and port users, differentiating them as needed for emergencies and unscheduled events responses. Our solution aims at being cost-effective, timely, and efficient. Naturally. Well, in October 2019, the European Commission and European Investment Bank announced the launch of a European Drone Investment Advisory Platform to support innovation and investments in drones. Since then, a number of projects have been proposed to make the most of the emerging technology. Here are some. AirMore project that focuses on the use of urban air mobility systems for moving medical supplies in order to develop a toolbox for aviation urban authorities, for example. The MobNet project that aims at locating isolated victims during natural disasters, earthquakes, hurricanes, snowstorms, etc. Ambulance project that has the goal of developing an electric vertical takeoff and landing air ambulance. And the Saphir Med project that aims at moving medical goods among hospitals and other locations. Besides, a number of interesting researches have been started to verify the potential benefits of the drones in other areas. The Port of Antwerp uses drones for surveillance flights. The Port of Amsterdam, on the contrary, uses sailing drones for various tasks, for example, scanning the bottom, measuring water quality, inspecting art to reach locations. The Port of Rotterdam is studying different drone use cases, actually, monitoring incidents, water pollution, firefighting, surveillance, supervision of port operations, the security of port operations, inspecting installations at terminals, and so on. Recently, the Balearic Island Port Authority has initiated a pilot program to control and manage the public port domain by using drones in the port of Alcudia, supervising port operations and also for environmental control. Still, there is something to do. Indeed, there is no known solution referring to the continuous communication between the authorities and the port users for managing emergencies and unscheduled events. Therefore, we propose an integrated information system based on drones, RFID technology, and smartphones, and tested it in the Elba Island municipality, Tuscany, Italy. In the solution, very light active RFID tags have been installed on drones, and the drones have been located in correspondence of a number of points of interest around the island. Drones allow to identify all kinds of emergency situations, and by means of a central system, a sort of control tower, I dare to say, sends notification and alarms to all the smartphones within a given range from the event itself. Messages may carry information and suggest diversions or escape paths, for example. Actually, the main problem of creating an actual information system based on smartphone applications is the necessity to have the corresponding apps installed on the smartphones of private citizens. Due to comprehensible privacy concerns, this could be the weak link in the chain. Due to these considerations, we decided to integrate it with a tourist information and rewarding platform regarding the points of interest and the road danger points of the Abourraja. A number of active tags, identical to those mounted on the drones, are located in the Elba Island's main tourist points. For example, Napoleon's House, Elba Mineralogical Museum, archaeological museums, and so on. At the same time, they are located near road danger points in order to deliver information about significant tourist nodes or alerts for eventual traffic or emergency issues. We see here a small screen capture from the Control Tower application that manages points of interest, events, and the related communications. The platform monitors the tourist flows, the gatherings of tourists, and manages them, encouraging the less frequented tourist hubs while trying to reduce crowding and traffic or potentially dangerous situations. This is done thanks to the connection to with the Good Go reward system, which allows to reward those tourists who visit the suggested locations. Tourists get credits for reading and using the multimedia contents, and with this they may book vouchers with which, for example, they can move to local shops adhering to the initiative and buy discount products. In this screen capture, it is possible to see the Good Go smartphone app that manages the rewarding system. To summarize, the ongoing experimentation in Port of Araya and Elba Island is currently showing the first practical results. It is currently only available as an experimentation pilot program with a limited number of connections and drones. However, the software platform and the communications among the drones and the smartphones have confirmed the technical feasibility of the proposed solution. The incentive system remains the only way to make sure that tourists and private citizens agree to install and use the application. Since the system guarantees the privacy of the person being sufficient to close the Bluetooth connection to stop any communication with the system, this should be a solvable issue. According to some interviews and questionnaires, people have confirmed their interest in the proposed solution. All notifications sent during the testing stage and related to fictitious events, fortunately we didn't have incidents during the tests, or to real traffic situation or to other problems in the territory were delivered promptly and reliably to the smartphones involved in the pilot project. Naturally, some aspects still remain to be deepened. They relate mainly to the average and minimal distances among the drones and the smartphones, and to any sources of interference that could disrupt the signal, mainly if the recipient is moving inside a car. All those aspects will be investigated in the next future. Before closing my presentation, I wish to thank the European Union's Horizon 2020 Research and Innovation Programme that supported our project. Thank you very much for your kind attention. I'm here for your questions.
Thank you very much for your prepared presentation. Thank you, Marco. Many thanks. So it's time for questions. Dear colleagues, please. John, please go ahead.
Do you use any optimization or control theory in routing the drones? And I guess that's the actual question.
Okay, not for the moment. We are going to do it in a later step of the project. Actually, the project was intended to verify the technical feasibility of communication and to verify if people is actually interested in the solution. The next step will be optimizing the network.
Okay, well, DARPA does a lot of this work on optimizing drones. So I'll send you my email.
Thank you very much. Thank you very much. That will be interesting, and maybe we'll tackle a collaboration.
Thank you. Thank you.
Thank you very much.
Mohamed, I saw your hand raised. Do you have a question?
Yes, basically I had a question. In the beginning, I was wondering about, of course, thank you for the presentation. It was a very nice presentation and an innovative research. I was wondering if there were similar research done using the drones and as a tool for information visualization, and would be something really interesting to be implemented in the tourism scope. So do you know of a really similar experience or some research that is working in this direction? Dr. John just said something about DARPA. And,
okay, sorry, go on.
No, thank you. This is just the question. I was just wondering about the model.
That was our primary concern, in that we were convinced that some studies were already available in that direction. On the contrary, we found that drones have been studied under several point of view, several aspects. Safety, mainly in ports and periport areas as well. But what was lacking was the communication stage. We didn't find interesting or novel works in that particular topic, and thus we decided to deepen our experiment, just because it seemed to be something new. And the touristic approach that you mentioned before was our second goal, in that we didn't find a solution similar to the one that we used, and therefore we think that that could be an interesting field to be studied in the next future.
Thank you very much.
Thank you very much.
Thank you. Thank you. Thank you, you both. Thank you, John, and thank you all. Thank you, John. Thank you, Kirill. Any other questions, please? No. I don't see new hands raised at the moment. So again, Kirill, thank you very much for your very nice presentation, and we wish you good luck in your next steps in this research and maybe some other professional activities. Okay.
Thank you.
Thank you. Mohamed, do you think that we have colleagues from those missed paper joining us? What is your impression?
At the moment, I don't see them joining. Maybe we can just ask if someone related to the team, for example, is presented in the meeting, so they can also share their work.
Papers number 59 and paper number 26. Dear authors, are you here, please? At the list of participants that are currently present, actually, I don't see colleagues from the list of authors, co-authors of these papers. So this means that actually we completed the session. We received the papers that were presented, and we had a pleasure to discuss them. So let me cordially thank all colleagues that took part in our session. My special thanks to Mohamed for very kind technical support. Thank you, Mohamed. Okay, and now we could have a break between the sessions, and then let's join next sessions. John, you have something to tell?
Oh, we have a lot of optimization research from DARPA and stuff like that. Most of it's releasable to academics and stuff, but I always have to check. But I've noticed several people that might want some of the be interested in the research, but I'll have to check and stuff like that. Okay. Anyway, but there may be some free research from groovy old DARPA and stuff like that. Okay, I'm done.
Thank you.
Yep, California still here.
Okay, so have a very nice the rest of the day. By this, we complete the session. Thank you very much for your kind participation. Thank you. Bye.
Thank you.
Bye-bye.
Goodbye.
Bye.
Ciao. Things like that.
Bye.
Yeah. The slide rule is calculated that it's the end of the session.
Okay, thank you, John. Bye.
Thank you.